Virtualization is one of the most popular technologies that's out there right now. It's providing us with a lot of functionality, not only on our desktop environments, but also in our enterprise environments. What virtualization allows us to do is have many different operating systems all running on the same physical device. So on my computer, I might be running Mac OS X. I might have a Windows 7 system up at the same time. I might have a Linux box that's also running at the same time, another Windows server somewhere else. And it's using all of the same hardware, but now I've got multiple operating systems. They're all independent computers, as if I had independent systems all sitting right in front of me, but they're now all running on a single CPU, on a single set of memory inside of my computer. It's really an interesting technology because I can do this not only from a host-based perspective, and I've done this and shown you demonstrations where I've been running different operating systems on my desktop, but you can also run this functionality at a server level and have the server itself be the thing that is virtual, and you have many different computers now running inside of that single virtual server. That's what you generally see in an enterprise environment because it's designed to be managed on a very large scale. Interestingly enough, this technology isn't something new. It's really been around since about 1967 when the folks at IBM designed their mainframes to be virtualized. That way they could have a production area of the mainframe. They could set up this model office area where they can test different things. You got to have a development area of the mainframe. That way you can have these very large enterprises that are able to go through the process of developing software without affecting any other part of the organization. This is a screenshot of my desktop running a lot of different operating systems. I'm running Mac OS X as my native operating system. So I have a Chrome browser that's up here that's running a game. I have a Windows 7 system that's running right here in its own virtual machine. And I've got applications and browsers running in there. I have a Linux Ubuntu system here that has other applications running inside of that. All completely separate operating systems, all completely functional separate operating systems, and I'm all running them on one single desktop. The piece of software that's managing all of these virtual systems and allowing them access to my real CPU so that their virtual CPU can operate, and access to my real memory so their virtual memory can operate, is something called the hypervisor. And you'll often hear this referred to as a virtual machine manager. It's a little bit more than a supervisor. It has a hypervisor role because of all this virtualization that we have. And it's one that sometimes requires a specialized CPU. The CPU itself has to have a virtualization component built into it. There are virtual software solutions that will use any CPU, but you may end up having a bit of a resource hit because of that. If you have a CPU that's designed for virtualization, you tend to get much better performance from those. And this hypervisor is going to be able to manage the CPU and the networking and the security and the priorities and all of the different interactions between my native operating system and all of the other virtual machines that might be running at the same time. You have to remember that these guest operating systems are completely self-contained. It's as if you had a separate physical computer that you had on your desk that you were plugging into your network. And because of that, you have to load any of the normal security systems that you would load on anybody else's computer. You need antivirus, you need anti-spyware, you need to enable the firewall. Just because it's a virtual computer doesn't make it any less susceptible to any of those things that might happen with viruses and malware and attacks. So you have to make sure that you're putting all of those systems up there. You have to think also that the bad guys are thinking about virtualization, and they may be trying to install their own virtual machine into your environment. They may be doing that in an automated way. They're going to try to find ways to use whatever host system that you have. If you're using VirtualBox, they want to somehow get their own VirtualBox inside of your computer. If you're using VMware, they want to use their own VMware operating system on your computer. So it's not something that has been well used yet, but it's certainly an opportunity for the bad guys to take advantage of this, and just something you should keep in mind. If you have a third party, for instance, that's given you a virtual machine and says you should be running this VM, you have to take a step back and think about that, because you don't know what's on that virtual machine. They may have put information on that VM that would allow them access into your computer or into your local network. There may be a backdoor built in, or it may be a completely legitimate legitimate virtual machine. The point is you don't know. So you're going to first have to trust who's giving you that virtual machine, and then you may want to take that into your own lab and test it yourself and run your own scans and see if anything might be open that would allow someone access to that virtual machine that you really don't want. That host machine that is hosting all of those separate individual virtual machines is obviously a single point of failure. If anything happens to that host computer, you're in big trouble. If your hard drive fails, all of the guest hard drives are going to fail. They're all using that same drive. If you have problems with the memory, then you're going to have problems with all of those different virtual machines because they rely on that host machine running as perfectly as possible. If you happen to get access to the host computer, you're going to also gain a level of access into those guest operating systems. You can share folders, for instance, between the host and the guest. A bad guy could share a folder with some malicious code, get into the guest operating system, pull that information down, and now they own the guest operating systems as well. You also have to think about that the single machine that you're hosting all these operating systems is going to be under heavy use. You're already running one operating system. Now you're going to run multiple virtual operating systems, multiple virtual computers on top of the same machine. So it's going to use more disk access. It's going to use more memory access. Your CPU is going to be used a lot more. It's going to be hotter. It's going to have more things happening at the same time. So your mean time between failures is generally going to decrease. You'll have more failures in the same amount of time. That's a real challenge when you get into these systems. So you have to think about making these mission critical host systems a lot more redundant and resilient. If you lose a hard drive, you want to be sure that system continues to run. Well, a significant security threat then is going to be those hypervisors. They are really the overlay for all of the virtual systems. And the bad guys are thinking about that too. They've not really found any very good vulnerabilities that they can use yet, but it's one that they're constantly trying because they know if they can get malware on just one of the virtual machines, they can have that malware automatically recognize that it's part of a virtual machine and somehow communicate back up to the hypervisor and take over access or gain communications into the hypervisor itself and somehow compromise it. And they know if they can compromise the hypervisor that they could then gain access to any other of the guest operating systems on that computer. Well, now think about how this would be affected in a much larger environment. If we're talking about a service provider that's providing us with a virtual environment, we're just building our own server. We've got financial data on it. We've got personal data on it. We have no idea of anybody else that might be on this. We don't know of any other virtual machines. Those are other customers of that service provider. We don't have access to that. But if somebody was to find a way to take advantage of the hypervisor, they could get a virtual machine on that same device, gain access to the hypervisor, and potentially gain access into our financial data, into our personal data. And that's the concern we have, and that's why we want to be sure that we keep those hypervisors as secure as possible. The protection of these virtual environments from each other has therefore been a bit of a security challenge. We can't really take a physical firewall and somehow cram it into a virtual machine. So what we will generally do is separate the virtual environments. This is an example of a separation between different hosts. We'll have a web host with a lot of virtual machines on it. There's also virtual switches that allow us a little bit of security functionality between them. Maybe then we do put a physical firewall and we have a completely separate physical device that's hosting a bunch of virtual machines on the middleware or the back end. This allows us to at least have some level of separation, and because the firewall is right in the middle, we can be assured that the traffic between the web hosting side and the middleware or the back-end side is at least protected at that level. If you don't want to have physical separate virtual environments, you may want to keep everything on a single host. You could always separate things out into different networks. There might be a web services network, there might be a backend or middleware network, and you might separate those with a virtual switch or even a virtual router. We have all kinds of interesting virtual technologies coming along in these virtual environments. There's even an emerging market for virtual firewalls, so at least you can have some type of port filtering between all of these different components between your virtual machines and your physical network itself.